Today, we're looking at the very last object in one of astronomy's most famous lists, the Messier catalog. But, this isn't some grand finale. Nope. It's more of an intriguing afterthought, a celestial underdog called Messier 110. And here's the first thing that'll make you go, huh. Charles Messier did all his work back in the 18th century, but M110, it didn't officially make it onto his list until 1967. Yeah, that's nearly 200 years later. So that's the big question, right? Why? Why was this object, which is literally right next door to the amazing Andromeda galaxy, just left off the list for so long? That's the mystery we're going to unpack. Okay, so to really get M110, we've got to start with its totally bizarre history and the guy who first jotted it down. The weirdest part is, Messier definitely knew about it. Back in 1773, he made this sketch of the Andromeda galaxy and included this little companion. But he never gave it a number. It was just there. It took until the 1960s when astronomers were going back over the catalog for someone to finally say, hey, wait a minute, Messier discovered this thing, it should be on the list. And just like that, M110 was born. So now that it officially has a name, how do we actually see this faint, super distant object? I'll tell you, it's not quite as simple as pointing a backyard telescope at it. Let's walk through how the pros capture its light. All right, imagine you're in the control room of a massive observatory. First, this giant telescope swings over to the exact right spot in the sky. Then you pick a filter, let's go with red, to cut through all the background noise. The shutter opens, and for a full minute, a super sensitive digital sensor just soaks up all the photons that have been traveling for millions of years to get here. Finally, that data gets read out pixel by pixel to build the picture. And here it is. This is the result. What was just a little faint smudge in Messier's old sketchbook is revealed as this ghostly, beautiful dwarf galaxy. It also goes by the name NGC 205, but to us, it's Messier 110. And as you're looking at that image, just try to rack your head around this. The light that made this picture traveled for 2.69 million years to reach us. That is the mind-blowing scale we are dealing with here. Okay, so we can see it now, but what exactly are we looking at? Well, the data we've gathered tells a really fascinating story. M100 is what we call a dwarf elliptical galaxy. The easiest way to think of it is like a small, ancient city made of billions of stars. But unlike a lot of galaxies that have these super bright, dense centers, M100 is what we call diffuse. Its stars are all spread out, which gives it that kind of ghostly look. Now, this is where it gets really interesting. We can actually measure the motion of the stars inside M110. And when we do, we see something very, very strange. The stars aren't all moving together nicely. Nope. They're tracing out this really distinct S shape. That S shape is no accident. It's a scar. It's a telltale sign that this little galaxy is being gravitationally twisted out of shape, stretched and pulled by a much, much bigger cosmic force. And that clue? It leads us to an even bigger puzzle in astronomy. See, the story of M110 is actually a small piece of a much larger, unsolved mystery about how all galaxies, including our own Milky Way, get built in the first place. So here's the deal. Our best theories of the universe predict that there should be tons of small galaxies like M110 floating around. They should be everywhere. But when we actually look out there, we just don't find as many as we expect. So why not? I love this quote because it captures the problem perfectly. Small galaxies are supposed to be the builder rubble left over from making the giant galaxies. So if you're building a cosmic skyscraper, where did all the leftover bricks and materials go? Let's break it down. The theory goes like this. In the early universe, little galaxies form first. Then, over billions of years, they crash into each other and merge, building up the huge galaxies like our own. But that whole process should be messy, right? It shouldn't be perfect. There ought to be a lot of leftover pieces. But again, when we do a head count in our local neighborhood, we come up short. The answer to M110's strange shape, and maybe even the mystery of the missing rubble, seems to lie with its massive, overbearing neighbor. M110 is not alone. It and another dwarf galaxy, M32, are the two most famous satellites orbiting the absolutely colossal Andromeda galaxy, M31.
They are locked in this gravitational dance with their giant partner.
And that S-shaped scar we saw, that's the direct result of this dance. The immense gravity of Andromeda is literally pulling M110 apart. Astronomers call it tidal interaction. It's like a slow-motion collision stretching out over millions and millions of years.
Now, to figure out this whole backstory, astronomers get into some incredible detail. They study the chemical makeup of individual stars, what they call metallicity. You can think of it like a star's unique chemical fingerprint. This chart is a great example of how they use these fingerprints to trace where the stars came from and how they've all been mixed together by gravity over time. So let's bring this all full circle. Let's get back to our overlooked underdog and see why its story turns out to be so important.
That little companion galaxy, the one Messier drew but didn't even bother to give a number, has become a perfect, real-world laboratory. By watching how Andromeda is literally tearing M110 apart, we get a front-row seat to the process of how galaxies merge. And this helps explain that missing rubble problem. Maybe these small galaxies aren't missing at all. Maybe they just got eaten.
And we can get ridiculously precise about it. Scientists use these incredibly powerful computer simulations to match up what they're seeing, M110's position, its speed, its weird shape. This lets them basically hit rewind, reconstructing its violent past, and even predicting its crazy, looping orbit around Andromeda.
And that really brings us to the final thought here. M110 went from being just a footnote in an old sketchbook to a key piece of evidence in a major cosmological puzzle. It really makes you wonder, right? How many other seemingly unimportant objects are scattered across the sky, just waiting for us to ask the right questions and unlock the secrets that they're holding?